like this. Okay. Now, when I come to this quantum statistics, I think we did most of the discussion. Let me try to give the hint, okay, so that you can try to solve it again. So, can you see this one? I think quite dark. Consider a gas of CS atom, number density 10 raised to 12 atom per cc. Per cc means anyone?
Centimeter cube.
Centimeter cube, isn't it? When typical interparticle distance is equal to thermal de Broglie wavelength of the particle, the temperature of the gas nearest to, okay, again he said interparticle distance is equal to thermal de Broglie wavelength. Am I right? How we found interparticle distance? Any idea? D. V by n whole power 1 by 3. I have taken it like this. Somebody comment. While dealing with classical approximation, or while dealing with, I think, the problem that is mentioned in Griffith's quantum mechanics first chapter, last problem, I think we have solved that one. Am I right? Am I right or not here?
Yes, sir.
On which ground I have argued this one? I think I have taken a volume and I have divided that one into small cube. Am I right? And I have divided the whole volume into cube, again into small cube, number of small cube that is equal to total number. Okay, you should assume as many cube as that of total number, so that this volume is divided into n cubes. Okay, and assuming each cube have got what you call the what you call volume d cube here, so that again this d is the volume of the one cube, so that you can put one particle, so that d is equal to v by n whole cube. That's how we have written. Okay, whole raised to 1 by 3. Okay, now look at here, that this is what you have to remember. I think I have argued this one. Am I right? Now that is equal to thermal de Broglie wavelength. Again, look at here, lambda is equal to h by p, h by root of 2m into average kinetic energy. Am I right? Now average kinetic energy for a particle, I better write small e bar. Okay, so that's equal to 3 by 2 kbt. Why? That is for what you call again, this formula itself is called thermal de Broglie wavelength. Okay, 3m kbt. Now you have to equate this one to v by n raised to 1 by 3, and then you have to find everything. Okay, v by n, you can write it as again 1 by n by v, number of particle per unit volume, raised to 1 by 3. Okay, this is this v by n is reciprocal of density. I hope you can manipulate n by v here. Okay, then I think you can solve it for temperature. I hope you can do this one. Anybody who did and found the answer? Mass is needed here. I hope you can find the answer. Anyone who did the problem and found the correct answer, can you quickly comment? Nobody? I think you can do this one. I hope so. There is not much big deal here, isn't it? You can just use this formula. You should equate them. Okay, he said that when typical interparticle distance is equal to thermal de Broglie wavelength. That's what he said. Okay, that's why you should equate and you should find that one. I hope you can deal with this one. uh, what happened? I think this is the question that I wish to discuss. So this is just depends on some proportionality. Okay, I hope again those who solve the problem can quickly comment here. Bose-Einstein condensation occurs in a liquid helium kept at ambient temperature 2.17 Kelvin. Okay, for helium, again for typical helium, again helium 4, it is Tc is equal to 2.17 Kelvin. Okay, At which temperature will Bose-Einstein condensation occurs if helium gas, again in helium gas state, if density of which is 100 times smaller than that of liquid? Okay. If again, suppose this is for one density, okay, suppose this is for one density, let me take n by v. Now you have some other density, or let me take this is for one row. For other density, again, if the density is decreased by 1000 times, so then what would be the corresponding what you call Tc, I mean whatever the so critical temperature. Now I need how Tc is proportional to n by v. Anyone quickly comment? Power. It's just a proportionality question. So can you hear me? Are you there? So can you hear me?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
What is this power? I think after derivation, I think I told you to remember this power. Am I right? This critical temperature. I think this is proportional to 2/3. Am I right? 2/3 here. Okay. So now, suppose again now the new Tc. So let me write this Tc is equal to some constant into n by v raised to 2/3. Now the new Tc, that's equal to c into n by v. This density is decreased 1000 times raised to 2/3. So that's equal to 1 by 1000 times c into n by v raised to 2/3. That's equal to, sorry, 1 by 1000 raised to 2/3. So that 1 by 1000 raised to 2/3 into Tc. Okay, the new Tc, that is decreased by this much. What is 1000 raised to 2/3? How do you find 1000 raised to 2/3?
Sir, I think 10 to the power 1.
100, sir.
100. Okay, 100. Yeah, yeah. I think 2/3. Am I right? Again, how do you do that one? I mean, simply.
Write
Okay.
1000 as 10 to the power 3, sir.
Okay,
Then
okay, okay.
cancel off
Yeah,
3 and 1
that's
by
it.
3.
That's it. Am I right? Yeah, that's correct. So 10 to the power 2. Hmm? Again, so Tc dash is equal to 1 by 10 to the power 2 times Tc. Remember, if this kind of question appears, usually it will appear in 5 marks, and definitely it is usually on the proportionality. Okay, look at here. Again, to derive this one, we might have struggled a lot. To understand Bose-Einstein condensation, we might have struggled a lot. But when you see exam question, which are basically on, again, last outcome and proportionality in most of the case, actually, if you take gate exam, in most of the questions are like this only. Okay, I hope you can deal with this kind of question. uh, Let me quickly take this one, okay, because you are worried about this particular question.
So what was the correct answer for previous question?
uh, I think it would be 1 by 100. Am I right? 2.17 divided by 100. You can multiply by 10, isn't it? 21.7 divided by 1000 Kelvin. Am I right? You can write it as 21.7 into 10 raised to minus 3 Kelvin, millikelvin. You can write as millikelvin. Okay, that's how he managed. I hope you can deal with that one. Is that okay?
Okay, sir.
Yes. So when I see this question, I think I told that again. I did a whole derivation of Debye theory because that they're asking this kind of question. Okay. Now look at it. At low temperature in the Debye approximation, Debye theory means again omega is equal to V into K. Okay. The dispersion, so relation is like this. And again, Debye theory, the contribution of the phonons to the heat capacity of the two-dimensional solid is proportional to what? Okay, that's what he asked. Now you should start with this one, rho of k vector d square of k vector. That's equal to, again, area area by 2 pi the whole square into d square of k vector. Okay, then rho of k dk, that would be equal to a by 2 pi the whole square into 2 pi k dk. Do you remember this one? Quickly somebody comment. In case of 2d, you said 2d, so the same dispersion relation. Now rho of omega d omega, that's equal to rho of k dk, isn't it? Yes, tell me.
Sir, your voice is buffering.
So anyone? So am I audible?
Yes, sir, it's clear.
I think the problem with your internet. Okay, 2 pi k dk by d omega into d omega, or I think you could have gone for e by s minus 1. Am I right? Again, I think I have given how density of state proportional. To be better not to do this one, isn't it? Quite unnecessary. So E is equal to h bar omega. E is equal to h bar omega. Dimension is equal to 2 here. S is equal to 1 here. So that rho of E proportional to e power d by s minus 1. So that's equal to what is d? 2 e power 2 by 1 minus 1. Am I right about this one? E power d by s minus 1. I think this is the formula that I have given. Am I right? So that you can write rho of omega, that is proportional to, look at here. So energy is related to omega. So rho of omega, that is again e power 1, e power 2 minus 1, e power 1, that is proportional to omega. That's why rho of omega d omega, you can write it as some constant into omega into how to write d omega. You can write like this. You can quickly grab rho of omega d omega. Then you should go for energy idea again, that is 0 to some omega d. Am I right? Again, how do you write h bar omega? H bar omega, again it was photon statics e power beta h bar omega minus 1 and rho of omega d omega, isn't it? So then the whole thing, so rest of whole thing is substitution. Am I right? Again, energy f of E into density of state. This is the, so this is the average energy. What I can write is again some constant into again 0 to omega d. What I can write it as omega square d omega whole divided by e power beta h bar omega minus 1. And what you can do here is you can put beta h bar omega is equal to x, and again omega is variable. D omega is equal to x by dx by beta h bar. When you substitute this one, what would happen is omega is equal to x by beta h bar, d omega is equal to dx by beta h bar. When you substitute, what will happen is omega square x square by beta h bar the whole square whole divided by e power x minus 1. The omega is dx by beta h bar, so that what came outside was 1 by beta cube. Am I right? Into some integral. Again, you can approximate that integral to be 0 to infinity by some approximation here. That is x square dx divided by e power x minus 1. This is some constant value. Don't worry about that one. Again, grab all of other constant to see. Now again, this is required. Average energy proportional to T cube. Then specific heat proportional to T square. That's the idea. Is that okay? Dimension does matter. You better to write do like this, because you better take this density of state directly, because you should spend time on this one. I mean, this one means again substitution of this one. Okay, so substitution and grabbing the temperature term outside, that is the substitution and taking temperature term outside. Am I right? In that part you need to spend some time. That's why you should skip finding the density of state and all. You better take this formula directly, where d is the dimension. Yes, this is the power of k in E and K relationship. Okay, quickly, any question on this one?
Sir, we do the substitution only in case of when it's give the phonon statistics.
Yeah, again this is phonon statistics. Am I right? Again, this is photon. Again, this is mu equal to 0. This part, this is mu equal to 0. Average energy occupation probability multiplied with density of state. Am I right? This is the average energy. This was our debate theory actually. The only thing is this was different here in this case because you have two dimension. This functionality is different. It does matter for our answer. Okay, I think that is correct. Okay, t square is correct. I think answer key is not matching, but t square is correct. Okay. Yeah. Any question on this one? I think you should able to solve this kind of question.
Sir, I have a question on Ising model.
Yes.
Sir, while modeling the Hamiltonian,
Yes.
in the presence of magnetic field, we know that the potential energy is minus mu dot into H. But here we have neglected that. While taking the interaction between the two neighboring atoms,
Yes.
we have taken negative sign. So I want to know the reason of both the cases.
I think you are you are talking about again. So there are two interaction. One is interaction between the particles. Other one is interaction between with the particle with the surrounding, isn't it?
Yes, sir.
That's what we have taken. I think we have taken minus j into si, isn't it? Again yes I judge like that. Plus again something into yes I judge. Yes, jz like that. Am I right? And we have seen that's the summation over I comma j I not equal to j like that. I think we have written like this Hamiltonian. Am I right? Ising Hamiltonian.
Sir, actually, screen cannot. I
Okay, okay,
can't see
okay,
your
okay. Wait,
screen.
wait, wait. I just forgot to share. So can you just repeat your question quickly?
Sir, I want to know that while designing or modeling the Hamiltonian in case of Ising model,
Yeah.
we know that the potential energy in the magnetic field, in the external magnetic field, there is a negative sign with mu dot h.
Okay. Minus mu
But
dot h.
here
This
we
was
have
your yeah.
neglected that.
No, no. That negative sign you
Yes, sir.
can take it with
And
j actually. Isn't it? In Ising model, we want to simplify the Hamiltonian. I think so. Can you quickly tell me what is the typical Hamiltonian that I have written? Whatever you remembered. Actually, I couldn't watch that video again. Yeah. Your total Hamiltonian. So again a part of that one. Can I write like this summation over yes I z I is equal to 1 to n. Suppose so there are n what you call atoms like that, isn't it? Again, what is the coefficient you have taken? J. So can you quickly reply?
yes, sir.
Or we better take a typical question. Am I right? Or yeah, so let it be. You are saying that there should be negative sign here. Am I right? This was the interaction with the external field. Am I right?
Yes, sir.
Now look at here again. While modeling, yeah, you said that Hamiltonian should be minus mu dot b, isn't it? Now look at here. When you write mu for electron, okay, what will happen is minus e by 2 again e by m into spin, isn't it? And if you take magnetic field along z axis, this whole thing going to be again positive, isn't it? Mu so what is that? EB by M into again if you take B along Z axis SZ. Am I right? Look at here. This coefficient is positive. Are you getting my point?
Yes, sir.
So again we have written that one. Okay, we haven't written this dot product. After dot product, look at here. SZ will remain along with some constant that depends on external field and all. We put that constant as J. So now that constant can be negative. For electron, it is negative. Am I right? For some other, again, suppose if something else is involved, again, this may be positive also. Isn't it? Suppose if a proton is involved. So it
Sir,
gives,
if
so yes.
nothing is given, if nothing is given, but only the Hamiltonian is given, and there is uh, subscript like S1, S2, S3.
So can you quote problem if you have?
Yes, sir. In case of three spin in a triangular shape.
Okay,
They
yeah.
are located at the three vertices of the triangle.
Yes. Yes, tell me. Now look at here. If you have three spin-off particle in a so on the so triangle, suppose. Wait a second. So then again, let me write it as S1, S2, S3. Okay. Their interaction with the external field, we are going to write it as S1 plus S2 plus S3 with some constant J. That's what we have written. Am I right? This is the interaction with the external field. This J will take care about that mu EB by H by 2 EB by M, this kind of factor actually. So can you just see that one? So plus again you should take interaction between them. I don't know what is the what you call coefficient that I have taken here. Let me write it as G. So into S1 S2 plus S2 S3 plus S1 S3. We have written like this, am I right? This part of the Hamiltonian, this is interaction between the particle, between these two and these two. Just like in case of our hyperfine splitting, we write SE dot SP. Do you remember? In case of hyperfine splitting, your H dash is equal to, you write it like this, some A into spin of electron, spin angular spin of electron and spin of proton. Am I right? You are going to take dot product. Similar to that one, you can write that interaction term like this, where these are quantum number. You can say these are quantum number. These are ms value. Okay, these are actually again S1Z. I should write like this: S1Z, S2Z, S2Z, S3Z, like that. I haven't quoted that Z actually, Z component and all, but you should imagine that that is Z component. And again, once you have Z component, its eigenvalues are actually plus or minus h bar by 2. So rather than writing plus or minus h bar by 2, we write plus or minus 1. So that is h bar by 2, why can't you absorb to this constant? Am I right? So that the whole symbols are quite easy to work with, isn't it? You don't have to take eigenvalue plus or minus h bar by 2. Rather than plus or minus h bar by 2, take plus or minus 1, isn't it? That's how we take. So similarly, we don't prefer writing S1Z, S2Z also here. We write just S1, S2, S3. You should know that this corresponds to Z component of spin angular momentum. And again, your total energy depends on its eigenvalue. In that eigenvalue, h bar by 2 may come. Again, you are going to absorb to this one. Okay, everything is there in this constant. Is that clear?
Yes,
So
sir.
so quickly comment. I don't know whether again in the exam they may give one more negative sign here, isn't it? Are you getting my point? In the exam, they may give negative sign here. Why not? Okay, so they can design like this. Okay, it doesn't matter. Only thing is you have to model again to make the whole model simple, or to what you call discuss some other part of the story. Again, we don't think of that notation. Actually, we want to make it quite simple as possible. That's why we write Si is equal to plus or minus 1, where I equal to 1, 2, 3. Okay, each of this value can be plus or minus 1, and find the energy. Okay, I can write energy like this: J into S1 plus S2 plus S3 plus some g into g, some other constant, s1 s2 plus s2 s3 plus s1 s3. Okay, so once I write energy like this, again s1 s2, again if you write Hamiltonian, this should be operator. Am I right? Z component of spin actually. Once you write energy, this should not be operator, this should be quantum number, where again these are a quantum number. I'm going to define like this: Si is equal to Si is equal to plus or minus 1. We can define like this. This is the whole modeling. And now actually in most of the case, they don't expect you to write the Hamiltonian. Okay, when you see old question regarding this Ising model, I think you might have experienced that. Again, most of the question, they were not expecting you to write the Hamiltonian. They have given the Hamiltonian. You just have to find either average energy or number of microstate or partition function and all, isn't it? Quickly comment.
Yes, sir. Sir,
Yes.
can we argue like that while if the interaction between the two atoms is repulsive, then we will take positive sign. Otherwise, we will take negative.
No, 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 no. Again, here you can't judge that whether it is repulsive or attractive. How to say? I think Reef stated something. I think I have stated that one. This interaction, am I right? You are talking about this interaction. This interaction is actually, again, this interaction with the external field, that may what you call responsible for, again, we have studied the paramagnetism. Again, this theory is behind ferromagnetism actually, isn't it? I think Reef also quoted as theory behind ferromagnetism, am I right? That's in the 10th chapter, I think. Have I quoted that one? The location of Ising model in the Reef?
No, sir.
I think it is in the 10th chapter. Okay, in 10th chapter, again, or you can just see the index, just go through Ising model. I think I mentioned some statement. It does depend on distance between the particle. Okay, this interaction state, this does depend on distance between the particle, but it is not because of what you call. Again, I think I haven't given physical interpretation how it comes, isn't it? Any physical interpretation that I did on this part? Can anyone quickly comment? I said that this is a consequence of Pauli's exclusion principle, isn't it? Have I said like that?
Yes, sir.
Yeah, again, that's quite difficult to understand. Okay, again, let me try to grab some more idea about this part. Okay, this spin-spin interaction. Yeah, let me try to give much more idea on that one. Okay, this part. Let me again. Somebody post the question on so like this again. Some again some more idea about this Ising model, or some more idea about spin-spin interaction in Ising model. Okay, external interaction we already know, that is actually minus mu dot b. This interaction actually we can even so derive in what you call electrodynamics also. Now what causes this interaction? Obviously it's a magnetic moment interaction, but again we should what you call comment on the strength of this interaction, what does it depend on and all. Okay, that may give much more insight.
Sir, if it is not given that the electron, it is not given that the electrons are interacting with the magnetic field.
Then only this will not exist, only this part exists.
Sir, I have just mentioned you in a question. Anila have posted that. Can you check the
Which one?
Slack?
Statistical physics.
Sir, I have just mentioned you. You can check in thread.
Okay, wait a second. Ravi. Yeah, yes, just tell me.
So can you solve that question? Here, there only negative sign differs a lot while modeling the Hamiltonian.
Okay. Now wait a second. They mentioned energy like this, or we better to take some question. Am I right? You again? Anyone posted Ising model question anywhere here so that I can quickly grab and solve?
Sir, I have just mentioned you in that.
No.
that
You
question.
again. You have written something, but you haven't written the full question. You have written something. So can I just explain the question, or let me create question and let me solve it? I think I solved one question or two question in the class. Not much, isn't it? Wait a second. I haven't taken any Ising model question. Yeah. Anyway. Yeah. Just tell me again. So what is the energy that they have given? Quickly.
So let me read that question.
Yes.
Consider three Ising spin at the vertices of a triangle,
Okay.
which interact with each other with a ferromagnetic Ising interaction of strength J.
Okay.
The partition function of the system
Okay.
at
Strength
temperature
J.
T
Okay.
is
They haven't mentioned that again whether J is positive or negative. Am I right? That's what you are saying. Now you are asking whether to take E is equal to Again, so wait a second. He said whether any external field.
Yes, sir. There is a ferromagnetic icing interaction of strength G.
Then that is interaction between them, not interaction with the external field. Okay, then your question is whether to, again, if it is S1, F2, S3, if we write like this, okay, your question is J into S1 plus S, again, sorry, not external field, J into S1, S2 plus S2, S3 plus S3, S1. Am I right? Again, whether you have to take negative sign here or not. Am I right? That is your question.
Yes, yes, sir.
Now look at here. It doesn't matter, I think. Does it matter? Suppose if you take negative sign or
Yes,
positive
sir.
sign?
Yes, sir. The answer will be different. If we take positive sign, then either of option A or option B.
Okay, 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 okay. I think then you should not take any sign. Okay, you should keep it as it is. Can you just tell me which question it is? So, question from any question paper?
No, sir. The PDF you have shared.
PDF or MCQs?
Yes, sir. The MCQs you have given
Wait,
the
wait.
Google form.
Yeah, actually, I just wanted to solve the question that I left in the last class. Otherwise, I could have read your comment and could have come out with that one. So, please post the original question always, okay? Wait a second, not this one. Quantum statistics MCQs. Is it in the quantum statistics MCQs?
Sir, I will post, sir.
Okay,
I will post. I forget just.
In quantum statistics, CSIR question number 16, sir.
okay. Thank you. Yeah, tomorrow I again let me again send one message at 5 o'clock. You just reply with a clear screenshot, okay, so that I'll keep it ready. Question number 16. Am I right? That's what you are saying. Yeah. What Reef has mentioned? Whether he mentioned negative sign, Ravi? I think you are talking about this question. I think you can see this question, isn't it, on the screen? Consider
Yes, sir.
three.
Yes.
Yeah, Reef has mentioned any negative sign? Or again, the theory that I have discussed in the class, whether I have taken a negative sign? So can
So
you hear?
while taking interaction with the magnetic field, you have taken positive sign, and while taking with the interaction with the neighboring atoms, you have taken negative sign.
Okay, 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 okay. I have taken negative sign when you take the interaction with the neighboring atom. Am I right?
Yes, sir.
I
Yes,
think
sir.
this is only the exceptional question. In question, as I have quoted, I think they mentioned Hamiltonian, but in this question they haven't mentioned Hamiltonian, isn't it? That is the problem. Or energy, how to write the energy in terms of S1, S2, S3. Let me think of that one. Okay, again, what is the most general thing that we have to take, whether we have to take coefficient positive or negative? Okay, obviously it should be of this kind of thing. Okay, I hope you got my idea. Now the question is whether there should be negative or positive. Am I right?
Yes, sir. That is my question only.
Yeah, so did he said that J is positive? No, nothing on J also. Okay, they should have mentioned that one. Okay, in the question they should have mentioned either Hamiltonian or interaction J and J is positive or something, so that we can think of any more sign while you write the energy. Is that okay? So take screenshot of this question and keep it over there. Okay, let me see some more reference, and I'll try to come up with the most general thing that that we do in icing model. That's what we better to remember, isn't it?
Okay, sir.
Okay, so thank you for raising that question. I think rest of all question, whatever on the icing model, I think they have mentioned the Hamiltonian? Anyone who can comment?
Sir,
Yes.
uh, in this link, I mean the CSIR net questions, the
Yes.
question number 42,
Okay.
I have also shared in Slack too.
Question number 42.
Yes, sir.
A thin metal film
this
of
question,
dimension. Okay. Yeah.
yes, this
Very
is a two-dimensional problem.
okay. The magnitude
Okay,
of the
in this
Fermi
case,
wave vector of the system. Fermi wave vector means K. Wave vector means K.
okay, right? Yes.
Yes. Yeah. In the free
So,
electron approach. Yes. Tell me.
yeah, my question is, whenever we try to find the number of states or number of electron, that is
Okay.
capital N,
Yes.
we integrate the density of states,
Yes.
the function like V by 2 pi cube or A by 2 pi square or
Yes.
L by 2 pi
Okay.
according to the dimension,
Okay.
and
Yes.
we multiply that with 2
Yes. Yes. Because he mentioned electron.
because
Because once he mentioned electron, that you should know that electron is spin-off.
yes. So my question is, whenever we multiply that 2, we got answer root 2 pi into 10 to the power 7.
Yes.
And if we don't multiply that 2, then we get 2 root pi into, I mean option 1.
Okay. Okay. Again, without multiplying by 2, you will get root pi into 10 to the power 7. With multiplying 2, you will get option 1. That's what you're saying.
Yes. So my question is, we have to multiply that 2 and we get the option 2 and the correct option is option 1. How, sir?
Okay. Then I have to think of some original key answer from CSAR.
Okay, sir. Maybe the key is wrong or
Okay. Yeah. Wait a second. Let me think of original again. So can anyone who can share the experience on solving this question quickly? It may again. It is issue about again key answer. Am I right? That's what you're saying.
yes, sir. Yes, sir.
But I hope you got the method. I think have you applied this one in case of two dimension? We should go for two-dimensional k space. I think I told this one. Am I right?
Yes, yes, sir. Yes.
Kx ky.
Yes.
Then again the region will be again at 0 degree Kelvin. All states will fall whose k value within this circular patch actually with kf.
Yes.
Am I right? We write
Yes,
rho
yes.
of k vector d cube of k vector. Okay.
Sir,
We
D
should
square K.
sorry. So d square of k vector.
Uh-huh.
And if you integrate from again within this circular patch, okay,
Mhm.
what would happen
Mhm.
is you will have again this is v by area by 2 pi the
2 pi
whole
square
square. Again
and
integral of d square of k within this one, that will become a by 2 pi the whole square. I
pi
think
K
this
square.
pi into kf square. Am I right? I hope you got this idea, isn't it?
Yes, yes,
So
yes.
then this should be equal to total number of the particle at 0 degree Kelvin. Am I right? This is
Uh,
count of total number of states within kf at 0
but
degree
what about
Kelvin.
the 2 factor?
Okay. Yeah, you have to multiply by 2 factor because again, so total number is double of that one. Now
Yes,
again, I think he might have given n by a in the question.
yes. We need to find n by a.
2 by 2 pi square pi into k. Okay, you have to find this n by a itself.
No, no. We have to find the
Kf.
kf, but
Yeah.
that n by capital N by a is, I think, he has given the number, electron number capital
Yes.
N, and
Yes.
the
Yes.
area we can find out by the dimension of that.
Okay.
I
I
mean
think
2
you will
mm
get.
into 2 mm.
Okay. So I think kf is equal to this one root of this one. Am I right?
Yes, sir. Yes, sir.
Yeah.
Yes, sir. So we have got that root 2 pi into root of n by a.
Okay. Okay. Root 2 phi into root of n by a.
Yes.
Now
So
again,
the
it's okay. 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 Again, let me so let me check out the key answer again. I don't know
yes.
which year.
My question is,
It's very recent question. Okay, 43rd, 42nd means very recent question. Let me check out again official key answer. Yes, tell me.
Okay, sir. Yes, we have got now the option 2, right?
Yeah, I think now, yeah, it is option 2, root 2 pi into 2 cross 2, yeah, again 4 by, but it is in millimeter.
Yes, sir. Whenever we convert that, we get 10 to the power 7. I have done it.
Oh, okay. Yeah, I think
Okay,
all powers are same. That's why we don't have to worry. We have to
yes.
choose one
So
of them. Yes.
my question is that 2 pi,
Okay,
2
okay.
root pi or root 2 pi.
Yeah, that's
Because
correct. I
if we
think
do,
root 2 pi, because this 4 and 4 will get cancelled, and 10 to the power, I think you can balance. I think that's correct. Okay, whatever you are saying, that's correct.
yes. So maybe the key is wrong,
Okay.
I think.
Yes. Let me check out that one. Let me check out official key answer. Okay.
Okay,
Yeah,
okay.
I hope you should have, again, these are actually believed to be condensed matter point of view questions. Okay, but theory is same. The same theory we apply in condensed matter. Okay, you don't have to think that this is condensed matter physics and we should again discuss that one separately in condensed matter. Okay. Yeah.
Sir, someone have commented. Please check.
Okay, in Slack, sorry, in
In Gmeet.
when we consider spin half fermion, we will multiply 2. If they don't mention spin, then we don't multiply by 2. Again, that's correct. Okay, when we consider, okay, when they give spin half, we should multiply by 2. When they give electron also, you should multiply by 2, because you should know that electron is spin half. But if they mention only fermion, don't multiply by 2. Don't take the that spin degeneracy. If they mention only fermion without mentioning that this is spin half fermion, don't take any factor. Don't take any spin degeneracy factor. Is that clear? So quickly comment. That's a very good question. Okay, you should clarify that one, because in exam we can't say that I just multiply by 2 again. You can't argue after the exam. That's why you should understand whatever they are expecting. Yes, tell me.
I think she was arguing for that question that there was not given any and there was not
Okay.
given
Yeah,
about
but
the
so look at here. I think I mentioned this one in class also. Okay, if they mention spin half fermion, or if they mention electrons, or if they mention protons, or if they mention neutrons, you should know that electron, proton, neutron have got spin half. Okay, you should take spin degeneracy factor 2. Okay, if they mention only fermion without mentioning whether it is spin half fermion, spin 3 by 2 fermion, then you should not take any factor 2, just like I have taken here 2. Is that okay? Is that clear? Is that okay? For these, again, if they mention what exactly particle we are talking about, that means you should know the spin of the particle. That's what they are expecting. Okay, just remember this one while solving the question. Yeah, in most of the
Sir,
question
one
they
more
mention.
question.
Okay, yes, tell me.
Yes, the 38th number.
Yes.
In that question, they have asked that the number density of free electron is increased by 8 times. Then what will be the Fermi energy? This question.
Free electron gas. Okay, look at here. One more thing that I think I haven't mentioned, that very important part that you should remember is, if they haven't mentioned anything about relativistic, or non-relativistic, you should not take relativistic. Okay, don't overthink in any question if they haven't mentioned relativistic or non again, because dispersion relation does matter in all of our question. Am I right? Energy proportional to k power s, this is very important part actually. So that's why if they haven't mentioned about relativity, don't take relativistic. Okay, if they especially mention the dispersion relation, or if they especially mention the relativistic case, again you better to take energy proportional to, again, energy proportional to p. Non-relativistic, energy proportional to p square. Am I right? Non-relativistic free particle, energy proportional to p square. Usually for relativistic particle, energy usually proportional to p. Okay. Again, one more thing that I have to quote actually, in none of the question they have just mentioned take relativistic case. They mentioned dispersion relation, But in case of non-relativistic case, most of the case they haven't mentioned again dispersion relation. Okay, if they haven't mentioned anything about relativity, take E is equal to h bar square k square by 2m. That is nothing but p square by 2m. Is that understood? Somebody quickly reply. I'll get to my point. You should not think that whether they are talking about relativity or non-relativistic case. Yes, tell me.
Yes, sir. What about for graphene?
What about no? If they mention graphene, look at here. In some question they mention graphene. Along with that, I think they mentioned dispersion relation. Look at here, dispersion relation of they have mentioned in case of 2 dimension. Look at here. This is the question that I am expecting. Am I right? The dispersion relation of gas of spin of fermion in 2 dimension is E is equal to h bar v into k. Am I right? Energy proportional to k means energy proportional to momentum. Am I right? In case of 2 dimension, they mentioned. Okay, in case of non-relativistic case or in case of something else, they will mention the dispersion relation. But in case in case of relativistic case or in case of anything else, they will mention that one. If they haven't mentioned anything, then again if they haven't talked about relativistic ideas, then you should take non-relativistic expression. Okay, you better remember this fact. Now whatever the question that he is asking, I think this one, am I right? Number of density of free electron in the gas increased 8 times, its Fermi energy will be. Now look at here, I'm going to solve it like this. Okay, so obviously you should take, again he said gas, am I right? He said gas, then he said so gas means it should be 3D. Can I say like this? Number of density of free electron increase a free electron gas, it is increased again, and he hasn't talked about dispersion relation. Then I'll not worry. What I'm going to do is I'm going to take dispersion relation energy proportional to k square. Okay, so now dimension is equal to 3. Okay, and s is equal to 2. Am I right? K power s, energy proportional to k power s. Then your rho of E, that is proportional to e power d by s minus 1. Can I write like this? That's equal to e power, what is d? That's 3 by 2 minus 1. Can I write like this? That's equal to root e. That's what happened in case of 3D. Rho of e was proportional to root e. That you have already remember. I think it is proportional to root e. Okay. Now look at here. So go for total number integral 0 to ef, isn't it? Again f of e, rho of e, dE. Do this calculation at t equal to 0 degree Kelvin. For t equal to 0 degree Kelvin, again he mentioned electron, you should follow Fermi direct distribution. Okay, take factor to whatever you take. Okay, now whatever you do, look at here, this rho of e contain volume in the numerator, don't forget. Okay, so then f of e will be equal to 1 at 0 degree Kelvin between 0 to f, so that this integral is going to be volume term will come, some constant will come. Okay, along with you have to integrate 0 to ef root e. Okay, so that is going to be n by v. Okay, constant here, ef power 3 by 2 divided by 3 by 2. Can I write like this? Root e integration is again e power 3 by 2 divided by 3 by 2. Grab this 3 by 2 constant because he is expecting only proportionality. Question is proportionality question. Ef proportional to n by v raised to 2 by 3. If you remember this one directly, in case of 3 dimension, in case of non-relativistic energy, that's okay. But you should do it like this. Is that clear? Now look at it. I haven't taken much time to solve this one. So now,
Yes, sir. Actually, I was making a mistake of n by v proportional to 1 by 3. Actually, it's 2 by 3.
you better to do this one because in some other question you may need to do this step. Okay, that's why you better practice this step actually. That's what I'm expecting. Is that okay?
Yes, sir. Yes.
Now what I'm saying is, look at here. Now I think what is said, density is increased by 8 times. Am I right? What is 8 power 2 by 3? 8 power 2 by 3. 8 you can write as 2 cube power 2 by 3. That means 2 square, that's equal to 4. Am I right? Fermi energy will be increased by factor 4. Is that clear? And usually this kind of question would be 5 marks question. Okay, and you should not miss that chance actually. Is that clear? Again, people on YouTube, are you facing any difficulty because I'm just switching over to one tab to other tab? Again, tomorrow let me assemble all of the question one side and let me solve. Okay. Yeah, any further question quickly? Actually, I while revising, I'll solve some more question. Okay, right now you better to ask only difficult question. I think I don't have to solve this question again because you can manage. I better to give the hint. For two-dimensional free electron gas, the energy density, electron density N and Fermi energy EF are related by. Again, you should do the problem. Okay, two-dimensional free electron gas. Look at here. He hasn't said it is relativistic. Have you observed that one? Two-dimensional free electron gas. That's what he said. Okay, he hasn't said take relativistic or take some particular dispersion relation. Then you have to, what is the dispersion relation you have to take? E is equal to h bar square k square by 2m. Okay, now again you should do the full problem why he is expecting. Look at here, exact answer here. Okay, the electron density and Fermi energy. Now you should find rho of EDE. This is needed. Okay, in including all of the term, that's equal to rho of k dk, isn't it? I think I told this rho of k dk can be written as area by 2 pi square in case of two dimension. He said two dimension. I think 2 pi k into dk, that can be written as k is equal to actually root of 2m e by h bar a by 2 phi root of 2m e by h bar dk by de into de. I think de by dk h bar square k by 2m, isn't it? I think
Sir,
yes, tell me. Any
since
other
it's
quick?
yes,
Yes.
since it's two-dimensional, can't we direct write pi k square?
Okay, that's very good, clever idea. Again, we can write this one. Am I right? Total number. Again, just like the earlier idea I have taken, isn't it? That's what you are saying.
Yes, sir. Whenever you do
Huh.
the integral, that
Yeah.
2 pi k dk, you will get the same answer, pi k square.
Okay. That's good idea because anyway you need to integrate. Am I right? To get total number, isn't it? Again, you better to follow that one only. So that's a good idea. Am I right? Again, finding total, writing the expression for total number directly. Okay, at 0 degree Kelvin, all the state whose kf value between whose k value between 0 to kf. Am I right? Which is completely filled. Yeah. Yes. Somebody is asking the question.
Sir, why you not applying here e raised to power dy s minus 1
No,
to
again,
density?
there, look at the answers. Look at here. Without seeing the answer, you should not solve. Look at the answer. He is expecting exact one. He's not expecting any proportionality. Look at here. Option A and option D both have the same proportionality. Option B and option C, those are also have the same proportionality. You need including factor, isn't it? You can't do, again, earlier question, you can do approximation because he is asking how much time it is increasing or what is the ratio. Okay, that's why, again, look at here. Without seeing the question, if you start answering the question, definitely you will end up with a trouble. Now see the option properly. When I see the option, he's not only talking about proportionality, he's talking about factors also. That's why you should do the problem exactly. Now look at here. This part, as he said, again, this is a ideal method. Again, it will not take much time. Okay, you can go through this method also. You should practice. Again, I said one more method. I think that's given in REEF or some condensed matter physics book. You better write total number directly. How do you write total number? By counting total number of state. Okay, he said electron, you should take factor 2 into integral of rho of k d cube of k, sorry, d square of k, because he said it's a two dimension. D square is so d square of k. Now 2 into area by 2 pi the whole square. This integral is going to be again area under this shaded line, whatever I have written, that will become pi into kf square. Am I right? Pi into kf square. Again, this is total number of state at again, this is total number of state between so whose kf value is within 0 to kf. Okay, whose k value within 0 to kf. At 0 degree Kelvin, all of these states are completely filled. That means counting total number of states again within kf at 0 degree Kelvin, that's equivalent to counting number of particles, because That's how we define kf. Am I right? Again, our at 0 degree Kelvin, again our energy up to kf is completely filled. Beyond that one, it is completely empty, like that. Okay, we call this again, in case of 3 dimension, we call it a Fermi sphere. Are you getting this idea? This is very good technique. Are you getting this idea? Anyone who haven't got this idea, tell me. I'm going to explain it again. I think I explained this one in class. Am I right? Counting number of state at 0 degree Kelvin, counting number of state up to Fermi energy, because this is the idea. Okay, again at 0 degree Kelvin, okay, suppose if you take like this, all of these states are completely filled. Am I right? Can I say like this? This is EF, this is E1, E2 and so on. Okay, counting number of states, okay, including regions. Suppose that is so double the number of state whatever you count actually. So again counting number of state at again up to Fermi energy, that is equal to number of particle at t equal to 0 degree Kelvin. Am I right? Or so total number of particle in the system, because at 0 degree Kelvin particle occupy up to, again particles are completely occupied, again states are completely occupied by the particle up to EF. That's why counting number of state, again how do you count? You should count translation state, number of translation state, then you have to double, because he said it is electron. So then double the 2 into number of translation state, okay. So that is equal to 2 into number of translation state up to Fermi energy. That's equal to total number of particle in case of spin half fermion. Okay, now this total number of translation state up to Fermi energy equivalent to this region in the K space. Are you getting my point? Somebody quickly reply. Now
Yes.
n by a, this is the density. Again I told density need not be always per unit volume. Now in this question, look at here, this n by a, that is called as density. Okay, don't think how to define density. He said 2 dimension. Okay, electron density means electron per unit area. Here I think 2 pi square is 1 by 2 pi. Okay, 2 pi will remain, kf square. Okay, now what you have to do is you need actually n only. Okay, this is nothing but n, whatever he talked about. N is equal to 1 by 2 pi into kf square. You better write kf square h bar square kf square by 2m into 2m by h bar square. You should balance this one, so that this one is nothing but EF. Am I right? 2m divided by 2 pi h bar square into EF. Is that okay? Now you can think of the options. 2 got cancelled. M by pi h bar square. M by pi h bar square into EF. This is the term. Is that okay? Any question quickly? Yeah, like that. I think we are again running out of time. That was one very nice question that I want to discuss. Some diffusion and all. Diffusion of the particle. He has given spin and all. I wanted to introduce some concept over there. Wait a second. Again, I better to. I hope you can do this question. Okay, one more question that is remained here. Let me quickly finish out this one. Okay, he said the energy spectrum of the particle consisting of 4 state with energy 0, E, 2E. Like again, so single particle energies are 0, E, 2E, and 3E. Okay, that ZB, ZF, and ZC denote the canonical partition function for 4 non-interacting particle at temperature T. The subscript, again you should find all of this. I think we did this one. Am I right? We did again. Now you have 4 particles. How many state you have? 1, 2, 3, 4, isn't it? 4 particle. You have 4 state, but in case of ZB, what I said, ZB is actually boson, fermion. Again, for again ZC, you can directly write. Okay, let me think of options here. 12, 16, 9, 12. Again 12, 12, 16 and 9. I think I can eliminate option. Let me think of this. Okay, you should not do all part. ZC means, what did you said? ZC means distinguishable particle. Am I right? Third one. ZC corresponds to distinguishable particle. Now ZC is equal to Z1 whole power n. Am I right? What is Z1? 1 plus e power minus beta e plus e power minus 2 beta e plus e power minus 3 beta e whole power 4. Number of particle is 4. Am I right? He said 4 particle. Now look at here. That is equal to, he mentioned something y here. Don't forget. What is that y? So write in terms of y. 1 plus y square plus y cube raised to 4. Can I write like this? Because y he mentioned e power minus beta e. E power minus 2 beta e I can write as y square here. So can I do like this? Now look at here. When you take to the power 4, what is the maximum power? Again, the total thing is polynomial. What is the maximum power? The maximum power is y cube power 4. Can I write like this? That is the maximum power. Y cube power 4. That is nothing but 12, isn't it? Y raised to 12. Okay. Now again we should again either option A or option C. Am I right? Because this is the third one. This is the third one. So again third one have got option again maximum power 12. Okay, either option A or option C. Okay, now look at here. Now you should go for, now which is the best one? Next one, the best one is, look at here. Now I have eliminated these two options. Look at here how I'm saving the time. I have eliminated these two options because again he said again these two options says ZC have got again so polynomial of the order 16, because but I got 4. So again maximum what you call power is 12 here. Now look at here, among these two, again look at here, fermionic system have got same power. Okay, that's why don't go for evaluating ZF, you should go for ZB actually, isn't it? You should go for ZB. Am I right? Now, in case of ZB, look at here, you have 4 states. You have 4 states, okay? 0, E, 2E, 3E. You have 4 states, okay? You will start distributing the particle. Am I right? You will start distributing the particle, okay? Again, you have 4 particles, 4 states. 4 particles, 4 state. It takes lot of time to again find the total number of possibilities. Look at here, what is this one? Ni plus Gi minus 1 factorial divided by Ni factorial Gi minus 1 factorial. What is this one? Number of particle is 4. 4 plus 4 minus 1 divided by 4 factorial, 4 minus 1 factorial. I think this whole thing. Can you just count? What is this one? 4 plus 4, 8 minus 1, 7 factorial, 4 factorial into 3 factorial. This is quite huge. Am I right or not? 7 into 6 into 5 into 4 factorial. Okay, divided by 4 factorial into 3 factorial. Again, so 3 I can write as 3 into 2 actually. 3 1 the, 3 2 the, 2 2 got cancelled. 35. Am I right? Don't try to find Z here. Okay, don't ever try to find Z here, because you got 35 number of possibility if I'm not wrong here. Okay, again don't do that one. So what you have to do is in Z, okay, what might be the maximum y power n that you can get, where y is equal to e power minus beta e. Okay, so then you should get e power minus again beta e actually. Okay, when you write the partition function for a total system, you write r e power minus beta e r. Am I right? Where e r is the energy of the total system. What is the maximum e r that you can get here? Okay, when all particles are here, it's a boson. When all particles are here, when all 4 particles are here, okay, what is the total energy? Er is equal to, that is the maximum energy, that the energy is equal to 3 into 4, 12e. Can I write like this? 12e. So then, so that for that particular possible state, okay, your part of the partition function, that's equal to e power minus beta 12E plus and rest of all, isn't it? This is the maximum energy, maximum possible energy, and that's why this is the maximum possible power, y raised to 12 plus and so on. Rest of all, again, for different possible distribution, you get different term. So this is y power 12. That's why bosonic have got also 12. I'm going to choose option A. I'm going to what you call eliminate option C also. This is how you should save time. Okay, here I explained. Okay, that's why it took little more time, but you should run in your mind within no time, and you should save as much time as possible. Is that okay? Any question here?
So if we need to find the partition function for this system, I mean bosonic system,
Yes.
then Z will be a very long term, right?
Yes, again, look at here. Again, I found 35 different possibility of distributing 4 bosons in 4 different state.
Yes, sir. Yes, got it.
Don't ever go for that one. I think this is a just question. Obviously, they expect this much ideas. Okay, they expect you to apply this much ideas. Okay, that's why two things are important. One is conceptual understanding, so that whatever they are expecting, you should be able to grab what they expect, what they are saying in the question. Okay, that you should grab. That's the conceptual understanding. Next one is alertness. Okay, alertness means again, if you are alert, definitely you will try to eliminate the option. Again, that's the next thing that they are expecting in many question, usually in gate exam, gate as well as just exam. Okay, so in just exam, usually answer are not what you call, you can't eliminate the option, they design like this usually. But usually in gate exam, they expect alertness also. Okay, they expect presence of mind. Both are important. Okay, conceptual understanding will lead you to understand the question and grab what they are expecting from you and what they are saying. And next one is again, presence of mind will lead you to solve the problem within no time, within less time. And again, they are expecting that one also. Is that okay?
Sir, if you try to find the power of in case of fermion, then how will you proceed?
Yeah, a fermion, again 1 1 1 1 here, isn't it? What is the total? 0 plus E plus 2 plus 3. Am I 2 plus 3, 5, 6, isn't it? Again, this is the only term, I think. In case of fermion, you don't have any other possibility. Okay, so total energy is 6E. So E power minus beta 6E. Isn't it? Only term. Am I right? Check it out.
Yes, sir.
Only term for proton. Yeah. Any question? Yeah, along with, look at here, one thing is, while I'm solving the question, one thing is observing the method and solving that one with the same method. Okay, another one is how I got this idea. You should think like that, how I got this idea, or again, what are the unnecessary things that I am avoiding while solving multiple choice question. Okay, this also you should observe here. Okay, look at here, I haven't went for calculation of ZB, isn't it? That was actually very unnecessary. Am I right? Again, I was thinking again how to eliminate option. That's why I started with ZC, because quite easy to write ZC. ZF was also very easy. Look at here, I have started with this one. Are you getting my point? I have started with ZC because I know ZC can be written as Z1 whole power n. Am I right? That's quite easy. Next one, I would have started with fermion. Why? Because fermion, very less number of distribution, total number of way of distributing fermion, isn't it? Only one way. So then I went for B. That's why look at here. I first found this one, that I found 12. Then I found for these two options, this part is same. Then obviously I don't have other choice. I should go for ZB. Then I thought again, look at here. I found this one, isn't it? I found this one. I found the number of possibility, whether it is viable to find Z. No, it was not viable. Then again, what I need only again maximum energy here to find the maximum factor of Y, isn't it? That's why when that maximum energy can happen, when all bosons are in the highest possible state. That's it. Okay, just you should know that along with the method, you should know that what I'm doing here, again, what is the approach to the question. That's quite important in exam hall. to solve the question in a very less time. Okay, now again we are at the stage that again I think you can manage that conceptual understanding along with my course quickly. Now it's a time, again we already spent so more than 2 months. Now it's a time to reorient your thinking towards exam. Is that okay? That's quite important, that we shall do now onwards. Is it clear? I hope you can do this one. I think we better close this session, and yeah, we shall start classical mechanics from tomorrow. Any further question? Tomorrow evening also we shall spend again. I'll just again ask you to post the question at least half an hour before. Then you just reply with a clear cut screenshot. Okay, so tomorrow, then you better to again I'll just prepare a file like this, because that will save time. Okay, because switching over to tab, that's quite time consuming. Okay, I think Ganesham was asking some question about BEC for
Sir.
photon. Okay, wait a second, 1 second. For photon you can't expect BEC because total number is not conserved. Okay, Bose-Einstein condensation is about drastic increase of number of particles in the ground state, so that is never observed for photon. That is already mu equal to 0. Total number, we don't talk about total number of photon. Ganashyam, are you there? I think is there on YouTube. Yes, somebody was asking the question.
What will be the effect in energy if we change Planck constant equal to 0?
Okay, if Planck constant equal to 0, your quantum mechanical thing will approach classical thing. One thing that you can take here is, suppose if you take any quantum system, if you take delta E, energy level difference, okay, usually that contain h bar. Suppose if you take your linear harmonic oscillator, am I right? Again En is equal to n plus half h bar omega, am I right? Energy gap is En plus 1 minus En, that's equal to h bar omega. Suppose if you take En plus 1 minus En, in case of particle in a box, I think this will be 2n plus 1 pi square h bar square by 2m a square. Okay, what I can say is, when I make this h bar tends to 0, my quantum energy levels are so closely spaced that again I'm not experiencing any discreteness in the energy level. That means when h bar tends to 0, so quantum mechanical thing is tending to classical thing. Is that okay? Quickly reply with much more doubt.
Sir, energy will be 0 or not?
Ground state energy will be 0 usually. Suppose if you take what you call suppose if you take your ground state energy of 1D box, pi square h bar square by 2m a square, am I right? Suppose if you take ground state energy of harmonic oscillator, am I right? What is that? E0. This was E1 actually. Wait a second, this was E1, this was E0, that's equal to h bar omega by 2, am I right? Ground state will be 0. Particle can be kept at rest classically. You better think of this one. When Planck constant tends to 0, your quantum mechanical thing will tend to classical. I think in Jatili, somewhere in the first chapter, he mentioned this idea. Yeah, any further questions?
Got it, sir.
Have you attended all classes?
Yes, sir.
I think I have started with energy expression, E as a function of k. Am I right? Rho of k, d cube of k. This one. Am I right?
Yes, sir.
Where you are getting the problem?
So, how to start this type of problem? How to approach that?
Now that depends on the particular problem. Look at here. Let me take one problem. Okay, let me take this particular problem, whatever on the screen. Okay, here
Yes, sir.
you should not, again definitely density of state is going to play the role in number density, but you should not go for doing that one. What you need total number, am I right? Again, just to see how I handled this problem and how I handled one more problem like this. Wait a second, one more problem that I mentioned somewhere here. This one.
Yes, sir.
So just find the difference. Now for this problem, yeah, I needed dispersion relation. I needed the density of state and their integral. Again, that integral also I handled in a different way. Okay. And what I did again, what I did in this particular problem, I never needed what you call multiplicative constant. I needed only proportionality in this one. But in this problem, I needed the whole quantity, pure quantity, including multiplicative factor. That's why I went for pure calculation. Okay. Now what I'm saying is why you need this method, this way that I have started here, isn't it? This is what I have done in class usually. Why we need this method, this particular method? Because let me show CSIR. This particular
Sir, I
question.
mentioned a question on of a gate, question number 29.
Okay, wait a second. So let me complete my campaign. When you see this particular question, whatever on the screen, is that okay?
Yes, sir.
I think I gave that question in class. This particular question needed that process of finding the density of state in terms of rho of k. You should write in terms of rho of k, then you should convert that one in terms of rho of EDE. This was needed, that one, okay? That's why I just what you call push that original method, but do that original method only if it is necessary. So this needs practice definitely. Again, why again which method I have to follow at that instant of time, that is presence of mind, that should come because of practice only. Is that okay?
Yes, sir.
And again, you should do original method initially, then you should apply the technique while solving multiple choice question, so that again that will be complete. Okay, you will not feel any different, you will not feel any difficulties, okay, later. I hope so. Yeah, you just tell me, you so you are asking something else. Okay, yeah, in the band, isn't it?
Yes, sir.
Yeah, I think you can follow the same procedure, but he has written the final answer in terms of k itself. He hasn't converted into energy. I get my point.
Yes, sir.
He said one dimension again. I think you can do this one. Am I right? Yes, yes. Tell me what is the problem in this question? Now look
Sir,
at don't think that this density of state or dispersion relation question is something else, something strange that we haven't discussed. Okay, the same thing we apply in what you call statistical physics, you can apply with all means. Okay, but if he said anything about Brillouin zone, for a time sake, don't solve that question. Let me discuss that one later. Is it clear?
sir,
Yes, tell me.
while solving this question, I multiply by factor 2 because it's mentioned including spin degeneracy. Am I right, sir?
Yeah, he said electron. That's why definitely you should take spin degeneracy.
Its question is the density of the state of electron including spin degeneracy in band is given by. So we can multiply by factor 2. Am I right, sir?
He don't need to mention that you should include spin degeneracy. If they mention electron, that means you should know that electron is spin half. You should include spin degeneracy.
Okay, sir.
I think that's what I quoted a little earlier. If you said
Yes, sir.
spin half particle or if you said electron, in both the cases you should take degeneracy factor.
If we count, if we take two factor 2 for degeneracy, then we got option 2.
Yeah, that's correct. Again, you have two options which are same. Definitely, those will differ. That's correct. Okay. Yeah, he said including spin degeneracy in the question, but even though he hasn't mentioned this one, you should take that one. Are you getting my point? That's what I experienced after seeing many questions. I'm just grabbing how they are designing the question, so that you should not end up with the ambiguity. Even though question is ambiguous, you can't argue after the exam. Sometimes they will not entertain your argument. That's why you should not be too much idealistic. You should be quite practical. That's what I'm thinking. Is that okay? Even though that spin degeneracy part is not mentioned in the question, you should have taken factor 2. Is that clear? Are you getting my point?
Yes, sir.
Because he said density of state. He hasn't said density of translation state. Are you getting my point? Usually in GATE exam, they will take care. Look at here, look at this question. This is quite 100% convincing, am I right? There is no ambiguity like whatever we are discussing right now here, isn't it? Usually in GATE exam, you will not end up with much trouble like this, okay? But if they mention only electron, if they talk about any Fermi energy related to number density, Fermi energy related to energy density like that, if any question like that appears, so you should take degeneracy factor, okay? Yes, again, somebody was asking some more question about this particular thing. Why I opened this one? Somebody asked the question. Can you just tell me what is the difficulty in that question quickly?
I think Anurag was
Yes.
asking.
Yes, Anurag, can you just continue?
Yes, sir, I may get confused how to start, whether take row K dk or
Yes, yes, you better
row
to take rho k
epsilon
dk.
d epsilon.
You,
Yes,
you,
sir.
you have to take rho k dk only. Look at here. Now, again, in case of one dimension, rho k dk is rho k dk only. That's equal to length by 2 pi into dk. Am I right? Even if you write vector,
Yes, sir.
again, since it is one dimension, it will be happen to be like this. Now this is equal to rho of ed, or now he has written capital E. Are you getting my point? It should not be symbol sensitive. Can I write like this?
Yes, sir.
Now E versus K is given. Okay, so that you can write dE by dk. Now rho of E dE, that's equal to L by 2 phi into dk by dE into dE. Now you can find this one. You can substitute, isn't it?
Yes, sir.
Now again he's asking rho of E, density of state. Am I right? That's equal to L by 2 phi into dk by dE, and he clearly mentioned take spin degeneracy. Is that okay?
Yes, sir.
This is number of translation state. Don't forget. Without that factor 2, it was number of translation state. Okay. If you take spin into account, each translation state will have 2 spin possible state if it is spin half particle. Ms equal to plus half and minus half. Okay. Don't forget. Counting number of state, including spin, is different. Excluding spin is different. I hope you got the point.
Yes, sir.
So
Yes.
I think that again. So can you see the question? Yeah, the dispersion relation for a phonon in one-dimensional monoatomic Bravais lattice with lattice spacing A consisting of ion of mass m are given by this one. Okay, where omega is the frequency of oscillation, k is a wave vector, c is the spacing constant. For long wavelength mode, the ratio of phase velocity to group velocity. I hope, okay, we shall discuss this one, okay, this part in condensed matter physics, pure condensed matter physics. I hope your phase velocity is equal to omega by k, okay. Your group velocity is equal to d omega by dk. The same relation holds, okay. The same relation holds even in case of phonon. I hope so. If anything else is happening in the theory, let me so revise and tell you, okay, or let me give the some ideas about condensed matter physics again in the later part of our syllabus. Obviously, you should do this approximation. Lambda very much greater than a means how do you write? K is equal to 2 pi by lambda. This should be equal to very much less than a, like that, isn't it? You should take like that. If lambda is very much greater than a, 1 by lambda should be very much less than a. If you take that idea, I think you can find the ratio. So anyone who did this problem? Now look at here. When k is very small, look at here. How do you write this one? When lambda very much greater than a, wavelength modes. So anyone who solved this one, I hope this will give the answer. Okay, can you just try this out? Anyone from old batch? So quickly reply yes or no. I think again this concept will come in optical mode and acoustics mode of phonons actually. Let me discuss. Okay, let me give some brief idea during condensed matter physics. I think we better solve it over there. Yeah, anyone? So somebody was commenting. Yeah, quickly. Somebody was commenting.
I'm saying no, sir.
Okay. We shall have a discussion. Okay. You just try this one. Okay. So try to take the what is said is ratio of phase velocity divided by group velocity. That means omega by k or divided by d omega by dk. So try to take the ratio and try to get into this approximation. I hope you will get some ideas here. Okay. That's what I'm thinking. What would happen is lambda very much greater than a, then what will happen to k into a? Am I right? Then lambda by a is very much greater than 1. What I can write here is, look at here. Can I write like this? If lambda is very much greater than a, so that you should convert the approximation to ka. That's a good idea actually, because you can approximate cos ka as 1 plus suppose what is that, 1 plus 1 minus theta square by 2, like that. Am I right? Cos theta, when theta is very small, you can approximate 1 minus theta square by 2 factorial and all, isn't it? You can do some approximation. That's what I'm thinking. This is very much greater than 1. What I do is a into 2 pi into how to deal with this one. If it is very much greater than 1, what I can write here is, let me multiply and divide by 2 pi here. Okay, so 2 pi 1 by k is very much greater than 1, or k by 2 pi is very much less than 1. I can write it as, sorry, ka here. Sorry, 2 pi by lambda is ka here. What I'm thinking is ka is very much less than 1. Again, that's what he's trying to give here. Okay, again, somehow this approximation you can convert into ka is very much smaller than 1. Let me quickly try to do this one. Okay, phase velocity, that is nothing but omega by k. Omega by k you can write as, look at here, root of 2c by m 1 minus cos ka, where k is very small, whole divided by k whole divided by d omega by dk. That means you should take the derivative of this one. If you take the derivative, what will happen? 1 by 2 root of 2c by m 1 minus cos ka into, how to write this one again, the derivative of inside quantity, 2c by m into 1 minus cos ka. This derivative is sine ka. You can write like this. Yeah, I think when you make some approximation here, when you take some approximation, I think you can take this one to numerator, isn't it? So am I right about, so derivative d omega by dk? Somebody quickly comment. 1 by root of this one, 1 by 2 root of this one into derivative of whatever inside. Am I right? Quickly comment. Yeah, someone.
Sir, 1a should be there.
Okay, again sine k, again you should take the derivative of k, isn't it? Ka inside into a, that's correct. So now this would be 1 by k. When I take this one to numerator, I think this will be 2c by m into 1 minus cos ka whole divided by 2c by m into sine ka into a. Okay, you can cancel out this one. What you can write here is again 1 minus cos ka whole divided by ka into 1 by sine ka. This is what you can write here. You can do like this. This 1 minus cos ka, when ka is very small, we can write 1 minus ka the whole square by 2 factorial. Okay, you should know how to do this kind of what you call, look at here. Ultimately this is a what you call numerical question. Am I right? Your answer should be usually in terms of some number or digit, isn't it? Again, obviously, that's why you should not keep any k or a here. Okay, that's why Again, why I haven't what do you call approximated cos ka nearly equal to 1, even though ka is very small, because that will not get cancelled. Somehow, look at here, I'll try to manage here. So look at this one. Again, you need some practice here. 1 by sine ka, and what I can write this numerator is 1 minus 1, this is 0, plus ka whole square 1 by 2 factorial divided by ka into 1 by sine ka. Wait a second, my approximations are not over. Don't make this one nearly equal to 0, okay? Or this one nearly equal to ka, so that I can do actually 1 by 2 factorial. What I can write it is here, I can cancel out one of the ka. Now at very small ka, sine ka divided by ka, that is nearly equal to 1, or you can approximate. So sine ka, that is nearly equal to ka, sine theta nearly equal to theta, so that again ka divided by sine ka, when ka is small, this also nearly equal to 1 by 2 factorial, that's equal to 1 by 2. So can anybody confirm this answer who posted this question? I hope you cross checked your answer. Answer keys are updated or not? Quickly, somebody comment. Quickly, someone. Are you there? Is that the right answer, Abhishek? We shall see this one. This is a model which is taken in case of acoustics and optical phonon modes. Actually, we shall see this one. Okay, in so condensed matter theory. Yeah, yeah. If you're not interacting again, I feel I'm alone here. Are you there? Anyone? Ritesh?
Yes, sir. This has commented. It is correct.
Sir,
Okay.
it is given 3.
No, no. Again, don't put the comment in this one. I mean, in Google Meet, okay? Because I'm not watching Google Meet anywhere else. I'm watching YouTube and again I'm just seeing the screen. Okay, quickly we shall get into next question. What?
Sir, its answer is 3.
3.
Hello? Yes, sir, it's given in the answer key, sir.
Okay. Abhishek is saying that answer is 1. I think I don't know where we went wrong here.
What, sir, in Google Meet,
Yeah, wait,
it
wait,
says
wait.
it.
I think I forgot this 2 somewhere here. Look at here. This 2 was in the denominator of denominator. Am I right? Then this 2 would come to numerator. Yeah, that's correct. That 2 factor should be there. I think he got this why 1. That's correct. Yes, yes, you are commenting something. That's correct.
Yes, sir, correct.
Okay. No, let me try this. Okay.
Sir, I think they are expecting us to remember the formula. I mean, whenever we derive the dispersion relation for in case of photon, I mean phonon,
Okay. No,
then we
this
directly get this.
here he hasn't asked anything about one thing is this density of state and all. Okay. He's uh, he's asking again some other condensed matter perspective. Again, that's
Yes,
what.
sir.
Yes, yes, yes.
Actually, I want to say that this dispersion relation will directly come in the derivation,
Okay,
and
okay. I mean, this is very famous theory in condensed matter physics, isn't it? That's what you
yes,
are
sir.
saying.
Yes,
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 yes, yes.
yes. And they expecting us to remember that. I think
Okay, 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 okay. Yeah, yeah. We shall
because
discuss that one. Okay. I too don't remember fully. I mean, I think it comes in some again. We haven't discussed much about phonon and its mode and all. Okay. We just discussed what you call some. We have just taken there is a quantization of elastic wave, and we just moved on. In case of statistical physics, in pure condensed matter physics, we shall put into discussion. Okay, that's a good idea. Yeah, I think that's quite what you call frequent or quite important derivation in condensed matter physics. We should take it in the other class. Okay. Now, so take this question. Suppose the frequency of phonons in one-dimensional chain of atom is proportional to wave vector. Okay, whether he said it is proportional to wave vector. N is the number density of the atom, C is the speed of the phonon, then the wave frequency. That's what he's asking. Uh, he said one dimension, okay, one dimensional chain. He said omega proportional to k. Am I right? Wave vector k. Let me write omega is equal to some constant into k. Some constant into k. Let me take it like this. If n is the number density and c is the speed of the phonon, then the dB frequency is. So anyone, can you quickly give any idea again?
Yes, sir. The constant you have taken, capital C, is actually the speed of phonon, small c.
Okay, c is the speed of phonon. Am I right? Then I can
Yes.
write as omega
So
is equal to c into k.
Ck. Yes. That
Omega
we
is
have
equal to
derived in
velocity.
classes
Yes.
v
Yeah.
into k. Yes.
Then we
So
need rho of omega d omega, isn't it?
yes, just yes, 2 or 3 steps. One dimensional. Just apply the formula.
Okay. Wait a second. This should be equal to n. Am I right? Because it is one dimensional chain. That's what he said. Not three dimension.
One dimension, sir. Yes.
That's why you don't have to take I think 3 phonon mode also. I hope so.
Yes. No need, sir.
Yeah. Again, you just have to equate these two. I think here comes the length. Am I right? What is this rho of omega? Do you remember this one?
L by 2 pi.
L by 2 pi.
Uh,
L by 2 pi into dk. Am I right? Dk by d
dk. Yes,
omega
sir.
into d omega. D
Yes.
omega by dk is equal to v, actually 1 by v. Am I right? 1
So
by
1 by
v.
c
Yeah, 1 by c into
d
d
omega.
omega is equal to n. N by L is density, actually. You can take this L here. So that omega d is equal to 2 pi c. N by L is n. Okay, I hope this is the correct answer. Am I right?
Yes, sir. I got that too.
Yeah. Now, one thing you should remember is, in case of three dimension, total degree of freedom. Again, in case of in case of d by theory, we did write like this. Okay, 0 to omega d. We wish to count the total number of possible modes, actually. So we put factor 3 because there are three polarization mode for each photon. 3 into rho of omega into d omega. This is total number of what you call states. So again, so total number of possible state, including that polarization state for phonon. So that is equal to total number of what you call degree of freedom of the whole system. Suppose if there are n atom. Okay, this was so what we used in case of three dimension. Obviously, this 3 got cancelled. Okay, but again, obviously, rho of omega d omega was different over there in case of three dimension. Here it is in case of one dimension. Don't forget. Okay, one dimension. Okay, yeah. Any question? Yeah. So quickly put your comments. So can you see this one? Again, he's asking, sir, we have to find FD or omega D. That's a very good question in the last question. I think when you see the option, okay, he's expecting omega D only. Okay, omega D is, loosely speaking, we can call it as a frequency. That's very good question. Whenever they again, sometimes they say frequency omega just as a frequency. Actually, this is angular frequency. Am I right? Omega, it's again actual frequency is 2 pi into f. This f is actual frequency, but when I see this pi is there in all of the option, and again we got similar thing, pi into c into n. I think whatever we did, that's correct. Is that okay, Abhishek? Again, that all does matter. Look at here, understanding whatever they are expecting. And again, you should not argue that you have given frequency, you haven't given what you call angular frequency. You should not argue like that. Okay, later, again, according to the situation, you should what you call analyze and solve that one. Okay, so practice that one. We should be quite practical. Again, I'm not getting. Yes, I think we better solve this question because a kind of approximation question. Two identical bosons may occupy any of the energy level 0 and E where E is greater than 0. The lowest energy state is doubly degenerate and excited state is non-degenerate. And assume that two particle system is in thermal equilibrium at temperature to calculate average energy. That's what he's asking. One thing that you can do is, again, you can go for partition function. Actually, again, ground state is doubly degenerate. I think I gave that idea that when it is doubly degenerate, even though there is only one energy level, so draw two of them, okay, so that you can distribute the particle. Excited state is E actually. So you have two identical boson. You can put both of the identical boson here. Wait a second, let me draw it again. These are degenerate level, both have the energy 0, okay. So both bosons here, one here, both here, one here, both here, one here. Am I right? Ni plus Gi minus 1 factorial divided by Ni factorial Gi minus 1 factorial. Okay, what is this one? Number of particle is 2, number of state is 3. Remember, including degeneracy. Minus 1 factorial divided by again I think 2 factorial, 3 minus 1 factorial is equal to 5 minus 1 5 into 4 again sorry 4 factorial, am I right? 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. I think 6, am I right? 1 2 3 4 5 6. Again, we haven't left anything. This is how you have to confirm, okay, whether you have left any number of possible way of distribution or not. Okay, now count the energy. 0 energy, okay, 0 energy, 0 energy. This energy would be
Sir,
E. Yes, tell me.
if they doesn't don't give the condition that the ground state energy is doubly degenerate, then we should consider only one level,
Yes, yes,
right?
we should consider only one level here. To again, look at here, this will have one wave function, this will have another wave function, both are different, okay. Both particle with this wave function, one particle with this wave function, other particle with this wave function. Maybe these two wave function may give the same energy, that's equal to 0. Are you getting my point? That's why
So,
you
sir,
have to.
if they said
Yes,
yes, so if they said that the ground state level is triply degenerate, then we have to consider
obviously you
three
should,
states.
yeah, you should take 3 level, you should imagine all 3 of the same energy. I don't have choice, okay, I have drawn one below, one above, but they should have the same energy because I need to distribute and count again. That's why for that one I have taken it like this. Is that okay?
Yes, sir, got it.
Yes. Now again, one here, energy E, both here energy. I think wait a second, energy 2E, one here, energy E again. Okay. Now your partition function is Z, partition function for total system, that's equal to how to write 3, is that 3 e power 0 3 times 2 times plus 2 times e power minus beta E plus 1 times e power minus 2 beta E. Okay, this is your partition function. You can find your average energy, that's equal to minus dou by dou beta of ln of Z. Am I right? So that's equal to minus how to write, so you should find ln of Z first, that's equal to ln of 3 plus 2 e power minus beta E plus e power minus 2 beta E. So that if you take derivative, minus 3 plus e power minus sorry 2 e power minus beta E plus e power minus 2 beta E multiplied with I think derivative 0, derivative minus 2e e power minus beta E. I think again minus 2e 2e e power minus beta E. I think I can take this 2e outside, e power minus 2 beta E here, e power minus beta E plus e power minus 2 beta E whole divided by 3 plus 2 e power minus beta E plus e power minus 2 beta E. Am I right? Anyone? I think so, someone who did the question, can you quickly comment if I'm wrong? Now what he's expecting is what will be the leading term of this one at low temperature. Low temperature means again let me take T tends to 0. That means beta tends to very high. Am I right? Beta tends to infinity. Okay, when this is very high, what he's expecting is, again wait a second, let me try to find this term, average energy divided by e power minus beta e. That's what he's expecting. Yeah, so you better to divide by e power minus beta e, so that 2e 1 plus e power minus 2 beta e power minus beta e would happen. So 3 I think 3 into e power, you have to divide, again wait a second, you have to divide whole thing by e power beta e. Am I right? I can write it as, I just divided numerator by e power minus beta e. 3 plus 2 e power minus beta e plus e power minus 2 beta e. Obviously when beta is high, or let me write low here, high here, when this is very high, can I neglect this part? This is TFR question, am I right? Anyone quickly comment? Not numerical one. I think that is nearly equal to, what would happen is when temperature is very low, that's nearly equal to 2E. Yeah, anyone who can comment? By 3, isn't it? At when T is very low. But for bosons, actually some, yeah, anyhow, again, our statistics says something else. But when you see this question, okay, one thing that you should understand, that you should go for this kind of thing. You should not go for any of our statistics, whatever we have discussed, okay? When you see the question, again, understanding, I should multiply by exponential minus beta e. Again, I'm trying to find this term, okay, Ganesh. I think I'm trying to find this term. I think I divided this term in the numerator, and I kept denominator as it is, so that when beta is very high, e power minus beta e, that is very low, that is tending to 0. When beta is very high, 1 by e power beta, or 1 by very high quantity, that's nearly equal to 0. Okay, now don't hesitate to put any comment. I think that is nearly equal to this one, but I'm feeling little uncomfortable because at low temperature, actually something very different would happen in case of yeah, anyhow, we shall see that one. Yeah, any further questions quickly? Let me try to give some idea. Okay, I too struggled with this question. Very nicely designed question. Consider a temperature T equal to 0. Consider a temperature T equal to 0 is separated into two components. So a cylinder at temperature T equal to 0 is separated into two compartments A and B by a free sliding piston. Compartment A and B are filled with Fermi gases made up of spin half and spin 3 by 2. A and B, S is equal to half, S is equal to 3 by 2. Particles again S is equal to half and S is equal to 3 by 2 respectively. If particles in the both compartment have the same mass, okay, ratio of the equilibrium density of the gas. Anyone, can you quickly comment how do you deal with this one? What will happen when you remove the again partition? Freely sliding piston, that's what he said, am I right? He said this is freely sliding piston. Again, what is the equilibrium situation? How do you relate that one to density? Quickly, somebody comment.
So the density means that number of particle per unit volume.
Yeah,
in this case?
yeah, that's correct. Density means number of particle per unit volume only. He's asking ratio of density, am I right? Ratio
Yes,
of
and
equilibrium density, rho again, or again, how to say, what is the symbol that we have taken for n? N is the density, am I right? Na by nb. Okay.
yes, so
Yes.
I mean, whenever we try to find the number, then I mean number of states or number of particle, we
Yes.
multiply that by factor by 2 in case of half spin, and
Yes.
in case of 3 by 2 spin, then we have to multiply by, I think, 4,
Okay. Then what you're thinking?
and just compare the densities then.
Then I think you will not get any of this option, am I right? You should multiply by again. You are thinking that the ratio will be 2 by 4 or 1 by 2 like that. No, there is no answer like that. You are forgetting this one. What is the situation of equilibrium? I think we defined all type of equilibrium: mechanical equilibrium, thermal equilibrium, and what is that other equilibrium? Uh, Mechanical, thermal, and chemical equilibrium. Am I right? Are you getting my point? Anyone?
Number of microstates will increase.
Definitely. Why? Because again, if spin is equal to 3 by 2, number of translation state would be different. Am I right? 4 times that of this one. But I mean, how do you
At
start? Yes.
equal temperature means when temperature is equal, then we get.
Look at here. He said temperature equal to 0. Again, I think you can't deal with the temperature again. Isn't it? That's good argument. Okay, whatever you have argued, that is very nice. But he hasn't said anything about the volume also. Am I right? Can you see that part? He's not talking about volume also. I mean, if volumes were equal, I think you would have done something. Okay, if volumes were equal, your spatial what do you call states would be same. Am I right? Number of spatial state for this one and this one, the density of state would be equal. You could have done something. Again, what I can do is uh, I can just draw the state for this one A, state for B. Am I right? I can start filling out this one. I can start filling out this one. I could have done something. Again, I can put 2 particle in each of this A. I can put 4 particle here, 1, 2, 3, 4. Like I could have done something, but whatever. Again, volume is not same. Volume information of volume is not given. Yes, tell me.
Sir, it is given that the piston is free to slide.
Yes.
Then can we say that when the piston acquires some position,
equilibrium,
then at that situation, the density, the ratio of density he is talking about.
No, you can't say that ratio density is. Yeah, that's what he's saying. Exactly. You understood the question properly. Again, it is freely sliding piston. Particle cannot exchange. Okay, it's a piston. Okay, it is compartment. This is not removed. Okay, I think I in the beginning I think I might have told that it is removed. It's not removed. It is freely sliding piston and it is free to move. That's correct. Your idea is correct. Then, so can you just proceed?
Then it will stable at some position.
Yes.
Because
Again, then after equilibrium, again, what is that situation? Which quantity is equal after it comes to mechanical equilibrium? It's a mechanical.
Sure.
Yes, tell me.
number of atom per unit volume should be equal.
No.
So pressure is equal now, sir, at equilibrium.
Yes. That's what I'm.
We can use the pressure equation.
Yes.
P is equal to 2 by 5 NEF. That is given in Patria for Fermi gas. From that we can find out.
Wait. One second. Again, you should try to derive it out. That's what I'm expecting. Now, I later maybe you can remember. What did you said? P is equal to
2 by 5 N times EF. I mean N times energy. That's what is given in Patria. Direct derivation. Page number 238 in Patria.
We shall derive it out. We shall again. I think we did this one. Again, not exactly this one, but in some other way. Okay. So that's correct. PA is equal to PV because look at here. He said sliding piston and he said equilibrium. Obviously, it should be mechanical equilibrium. Pressure should be equal. Okay. Now, how to connect that pressure again to density, how to connect that pressure to what you call this one and all. Okay, so wait a second, we should do some more here. I think in case of I think we did some derivation that pressure is equal to, I think I have somewhere here, in case of fermions, pressure is equal to 2 by 3 into energy density. Anyone, can you quickly comment? Average pressure?
Yes, sir. In case of fermion and boson.
Yes, sir.
Yes. Now, while finding this average energy, let me take average energy again factor 2 because of this one spin half. Again, let me write PA here. Let me if I take PA like this PB average, that would be, okay, wait a second, that would be 2 by 3 into, that would be twice of this one, E bar by V. Why? Because while finding E bar, you should take that degeneracy factor. Am I right? Can I say like this? So can I say like this quickly? Now you should find this E bar by V in terms of density. That is the next thing that you have to do. I think in some exam they ask that question also. How energy density depends on number density. Is that okay? So now we shall try to do that one. We shall try to do that one. I think again this may be for one of the situation, maybe for electron or something. Again, we better to make it quite a general statement. Now wait a second. What I am thinking here is how to relate this energy density to number density. Am I right? Let me write energy formula here. That's equal to 2 times 0 to EF. F of E is equal to 1 E into rho of E dE. Okay. So similarly, what I can write here is again let again as he has taken this non-relativistic particle, I think this would be 2 into uh, some constant into volume term would be there, volume term into, let me do it in a detail. Okay, later we shall find quite easy step, just like Ritish said, some formula. I think some constant into E into root E, this would be proportional to root E. If I take this dispersion relation in 3 dimension, h bar square k square by 2m, in case of 3D this would be root E, root into e power 3 by 2 EF power 5 by 2 divided by 5 by 2. I can absorb this 5 by 2 to this constant again, so that what I can write here is this factor is also important. E bar by V, that's equal to this constant divided by, let me write 5 by 2, let me keep that 5 by 2 as it is, EF power 5 by 2. Okay, now number density, number you can write it as again 2 times 0 to EF, whatever I am doing that I am doing for A. Okay, 0 to EF rho of EDE, that would be 2 times volume into the same constant, because this constant appear because of this rho of EDE, and I think integral 0 to EF, I think root EDE, that would be equal to again number density, whereas again n by V would be equal to, I think some constant divided by 3 by 2 EF power 3 by 2. Okay, now how, yes, tell me.
So while deriving the number of states or number capital N, we multiply by 2. But in case of average energy, did we multiply by 2?
Yes, definitely. We should multiply by 2 here as well as here, because look at here. This whole thing is number of translation state. Am I right? Again, we not only address translation, we should address spin state also. Definitely, in case of average energy, also that factor should be there. Degeneracy, spin degeneracy factor should be there in both number as well as average energy. Is that clear?
Okay, sir.
Now, what I'm saying is EF is proportional to n by V power 2 by 3. Again, I'm doing with detail. Okay, later you should find some ideas to do this one. E by V proportional to EF power, wait a second, I better to write this one as, this one as 2s plus 1, this one as 2s plus 1. Is that okay? So that term would remain, because that term does matter here. Am I right? What is the information he has given? That is spin, that is degeneracy factor is very important. 2s plus 1 is the spin degeneracy. Am I right? That's why what I can do here is I can put 2s plus 1 here, or EF proportional to, how to deal with this one actually. Somehow I need the spin degeneracy term so that I can directly use that one, make use of that one. Otherwise, again, I don't know whether it will come in the numerator or denominator. I better write this one as 2s plus 1. Okay, this factor as 2s plus 1 here. Now n by v 1 by 2s plus 1 is equal to anyone. So can you grab me some more easy idea here? 3 by 2. I think I should solve it for EF. Yeah, let me try to grab exact term here. Okay.
Sir, we can differentiate with respect to V, no, sir.
Which one?
This mean energy. We find mean energy, sir. Differentiate with respect to V, sir.
So that
We
it
get
gets
pressure.
directly pressure.
Yes.
Okay, that's also good idea. I think from that only we got this expression, isn't it? This expression is from that one only, isn't it? Now wait a second. This expression we got it from that one only. But what I am thinking is how energy density related to number density, where this degeneracy factor is going to play the role. Is that clear? That's what I need. Are you getting my point?
Yes.
I have used the same expression. Okay. Again, we shall get into this one again. Definitely, I hope this is the very famous problem. I think it is there in the reef also. I just quoted. Okay, in case of fermion, these are the relations actually. But I don't know again how to keep the degeneracy factor here. That is the problem. Okay, when I equate them, and I don't know how to, when you equate this one, how to connect that one to number density. That's why E bar by V, what I'm going to do is 2s plus 1, okay, c by 5 by 2. If I solve it for EF, what would happen is 3 by 2, 1 by 2s plus 1 into n by v whole power 2 by 3. Let me substitute as it is, raised to 2 by 3 raised to 5 by 2. Totally, this would happen to be 3 by 2, 1 by 2s plus 1, n by v whole power. Am I right? Somebody again later do this one. Okay, 2 by 3 power 5 by 2, 5 by 3. Okay, now E bar by V, again this also question. Okay, E bar by V, that is proportional to n by V power 5 by 3. Okay, n by V power 5 by 3 along with, I think, 2s plus 1 divided by 2s plus 1 whole power 5 by 3. Can I write like this? So that E bar by V, that is proportional to 1 minus 5 by 3. What is this one? How to write this one? Wait a second. Now I think yeah. 1 minus 5 by 3, 3 minus 5 minus 2 by 3, am I right? Or 1 by, or 5 by 3 minus 1, 5 minus 3, 2 by 3, 2s plus 1 whole power 2 by 3, n by v raised to 5 by 3. Wait a second. Now I can put this term now. Look at here, PA bar is equal to 2 by 3 times, okay, some constant, okay, some constant into, or let me write like this, PA bar, that is proportional to 1 by 2s plus 1 raised to 2 by 3, n by v raised to 5 by 3. Okay, or n by v, in place of n by v I'll put n a here. Similarly, PB bar, that's equal, that's proportional to 1 by 2s plus 1 raised to 2 by 3, n b raised to 5 by 3. Can I write like this? Now equate them. That means I can write like this again. SA, I better write SA here, I better write SB here, because this spin corresponds to A, spin corresponds to B. When I take the ratio, I think I need NA by NB, am I right? Or let me equate these two, because when these pressures are equal, Na raised to 5 by 3 by 2SA plus 1 raised to 2 by 3, that's equal to NB raised to 5 by 3 divided by 2SB plus 1 raised to 2 by 3. Later you should find some easiest way, okay? So that I can write Na by NB, that's what he's asking, raised to 5 by 3 is equal to 2SA plus 1 raised to 2 by 3 divided by 2SB plus 1 raised to 2 by 3. I hope I am not wrong. Check the calculation later. I think I have to raise the power raised to 3 by 5. So that 2 by 5, 2 by 5. Am I right? Power 2 by 5, 2 by 5. That means this is 2 raised to 2 by 5. This is 4 raised to 2 by 5. Or I can write as 2 raised to 2 by 5 whole divided by 2 square raised to 2 by 5, 2 raised to 4 by 5. So that 2 raised to 2 by 5 minus 4 by 5. So 2 raised to 2 by 5. You have that option. So can anyone quickly confirm whether that's the correct option or not? Try to do in this way first, okay? Later try to find any method. Is that clear? Yeah, so quickly,
You
somebody.
are getting 1 by 2 raised to 2 power 5, but you are getting 2 raised to 2 power 5.
Ratio
No,
of
it's
density
correct.
of.
Negative sign is there.
You have missed the negative sign, sir, in the last step.
Okay.
Step.
Yeah. It was negative sign, isn't it? Yes. 1 by 2
Yeah,
power
that's correct.
2 by 5. Yeah, that's correct. Okay.
Yes.
Try to do in this way because this is where you can feel. Am I right? You have equated pressure, but you better to do this problem again. I think this purely depends on density of state. Am I right? Dispersion relation, and try to grab this term also. Okay. So I better write EA here, EB here, whatever. Again, somehow I just grabbed this degeneracy factor in our calculation. Calculations are very ordinary. We deal with only these two type of integral, isn't it? Whole calculations were very ordinary type of calculations. Only thing is grabbing that degeneracy factor. That was quite important step here. Okay. Yeah. Any further questions?
Sir,
Yes, tell me.
initially you told for B it is 2 times 2 by 3 E by B. Why, sir?
No. I thought like that because in energy term it would come and all, but it is not. Energy terms are related. Okay. Again, if suppose if it would be like this, look at here. Only 2s plus 1 would come here. Am I right? You could have written 2 here. You could have written 4 here, isn't it? Or 1 is twice of other, like that, isn't it? Are you getting my point? If only energy term would be there. But again, here energy term doesn't matter. How energy term related to number density, because he is asking ratio of number density here, isn't it? Are you getting my
The
point?
expression that you have wrote for PA and PB.
Yes, sir.
Yes.
They are actually derived by using a spin half particle.
No. These things are for fermion. Again, for any fermion, if dispersion relation, relation is this one, h bar square k square by 2m, and if it is 3D, okay, so you can derive p bar is equal to any fermion as well as boson. I think. Okay, I think usually we discuss for fermion. It's equal to 2 by 3 into E bar by V. I think I did in class. Can you just check it out?
Actually, that is correct, but we have to calculate E bar for I mean, if that is a different system of spin half, I mean 3
Yeah,
by
that
2
is
or
what
something like that.
that is what I did. While finding E bar and N, I kept that degeneracy factor as 2s plus 1. So
So we
that,
can't generalize that like that. I mean, PA and PB and equate them by putting the spin.
yes. Now what
We
I'm
cannot do
thinking
that, I
is,
think.
look at here. What I'm saying is, uh, 5 by 3 here, 2 by 3. Am I right? What would happen is, these powers are not equal. Can you just see this one? Are you getting my point? That's why I just went for that calculation. Because here EF power 3 by 2 and your the degeneracy factor remains as a first power. Again, here also degeneracy factor remains as a first power. When you substitute this EF, this 2s plus 1 power would be different, actually quite different. That is very important. Again, it caused something different, isn't it? So can you quickly repeat your question or your idea?
Actually, I wanted to say that the pressure expression we have derived as
Yes.
2 by 3 into E average by V. That we have done actually spin for spin half particle. I think that's what. I want
We
to say.
dealt with spin half particle throughout our theory. Now that again, in case of spin half particle, I have taken 2 here, 2 here. Am I right? In place of 2, how do I got that 2? That's equal to, if S is equal to half, 2s plus 1 is number of ms value, isn't it? This is called as degeneracy, multiplicity, isn't it? Are you getting my point? That's
Yes,
why
sir.
I kept that term as it is. Again this is fermion, okay, this is Fermi energy, but I kept that degeneracy factor as it is, 2s plus 1. I kept it as a symbol so that I can substitute anything later, isn't it? So that one expression, if you wish to remember, obviously I think you might have remember energy density proportional to n by v raised to 5 by 3. Okay, this would happen usually. This kind of question also there. Along with that one, there is a dependency on spin degeneracy, that is 2s plus 1 raised to 2 by 3. Okay, but I don't expect you to remember that one. You better to practice so that you can exhibit this one. I think if you practice, it will not consume much time, and if you practice using this kind of method, you can solve some other question related to this one. That's what I'm expecting. Okay. Yeah, any further question? What I thought was, when I see the question, again, what I thought was, again, mu a is equal to mu b. I thought, again, look at it, if compartment is removed, actually, then it will come to chemical equilibrium. Then I think you may you can write mu a equal to mu b. Wait a second, then we can't write mu a equal to mu b, because then it's not identical particle system again when particles are shared. Okay, this again, what I thought was this one, but when I read the question properly, I thought that this one, definitely it's a mechanical equilibrium, not chemical equilibrium.
Sir, since the spins are different, so we can separate them, right?
So definitely, again, this is the situation that they have given. You have spin half particles here, you have spin 3 by 2 particles here, and freely moving piston. Okay, it is not removed. Okay, what I thought was, when I see the question, what I thought was, again, he might have talking about some chemical equilibrium, because mu is nothing but EF. EF is very quickly related to, can be related to n by v. Am I right? So I think you might have remember EF is equal to, wait a second, it's not working again. Yeah, what? So this is the problem with the Windows. Yeah. Wait a second. What I'm thinking is, again, if this happens, EF for A is equal to EF for B. This would happen if they are in chemical equilibrium like that. Then it would have been quite easy, because you know EF is proportional to, I think, n by V whole power 2 by 3 in case of, so 3 dimension, our ordinary non-relativistic dispersion relation. Am I right? And you might have made use of this one. But this is not the case what they have given. This is what they have given. That's the condition. Just observe. Very nicely designed question. Just question. Yeah, definitely. You have to find average energy. That average energy and number density, again, your degeneracy factor would come 2s plus 1. You should keep that one. Yes, quickly. Somebody was asking question.
Sir, but this whole.
Yes. Yes, Ritesh.
Let Smita talk, sir, first.
Yes.
Sir, what's wrong if we put directly spin for individual number for
No, look at here. Then you have to do two calculation for A, for B. Am I right?
Yes, sir.
That's what I haven't done. I found the dependency on 2s plus 1. 2s plus 1 is the degeneracy, because there are 2s plus 1 ms value for each s value, isn't it? That's again, that different ms value will cause the degeneracy, actually. That's why I found that factor first. Okay, I found that factor first so that I can write the factor for A, I can write the factor for B. Otherwise, you should have done the same calculation for both A and B. Try to avoid that one. Okay, it should come by while solving the problem. You should have that idea. Okay, you should avoid that unnecessary step.
Okay, sir.
And proportionality factor, look at here again, rest of all quantities are equal for both system A and system B. Is that okay? What does this constant contain? The constant which comes in rho of EDE, what does that constant contain? That constant contain mass, Planck constant and all. Am I right? I think you might have remembered 2m by h bar raised to 3 by 2. That's what we have written. Look at here, he said same mass. Look at the question. We haven't talked about mass here, isn't it? Look at here. Both have the same mass. So that where does mass is in this one. Suppose he changed mass, I should have taken that mass dependency also here. Okay, that's how you have to deal here. Is it clear?
Yes, sir.
Yes. So yes, Ritish, tell me.
So the whole idea has been derived totally different in Patria. Patria only I found that value as 2 by 5 EF. That
I
there we
mean
can derive.
yeah, I think now you can derive this one also. But what I'm
Yes.
thinking is here EF you should eliminate again, isn't it?
Yes, sir. Yes. That's what I'm currently seeing the derivation.
Then
I'll do that.
EF should be proportional to n raised to 2 by 3. If you substitute this one,
Yes.
I think that would be correct. So that,
Yes.
but
Yes.
wait a second. The degeneracy factor that is missing here, isn't it? Degeneracy factor is missing here again. Ritish, can you?
So no, sir. Even in degeneracy factor has been accommodated in that
N, isn't it?
derivation. He has in his derivation for
Okay.
non-latistic
Yeah,
case.
yeah.
He has managed it. He has
Okay.
given it as G and he has done it.
Okay,
Yes.
yeah, he kept that one as G. Yeah, that's a good idea.
Yeah. He
Okay,
has
that's
kept
a
it
good
in
idea.
as G and he has done it.
Yeah. So since we
That's what
directly took
Patria was given.
application, not derived for any particular system, we directly start applying for electron gas and all. I have taken factor 2 and I just explained why that factor would come. Okay, this is very good idea. Keep the degeneracy factor and keep that one at the end of the story. Okay, that's a good idea. But you should able to do this one because this kind of step may be helpful for other problem. Okay.
Yes, sir.
If partition again filled with different massive particles, okay, then you should concentrate on this mass also. Okay, that mass term would come in this constant which comes in this rho of EDE. Just try to find that one. Okay, it's all, once you know this method, it's all proportionality or dependency question. You should think very carefully. Okay. So again, look at here, a kind of thermodynamic idea which is fused to statistical physics idea. Thermodynamic idea means again equilibrium condition is pressures are equal. Again, that is we call it as thermodynamic equilibrium, isn't it? A dynamic equilibrium, mechanical equilibrium. That is fused with some quantum statistics idea. Okay, that's a very nicely designed question. Try to solve it fully.